So it only gave you a grade. All right. Any questions you remember being particularly challenging that you want cleared up, or? So not necessarily. So I can actually look at the questions. I don't know if they'd be in the same order, but I can look at the questions. I can't necessarily look at the answers. Well, I can, but I'd have to exit this. But the test didn't seem too different from the practice exam. So, all right. With 4t in it. So was it like dr d theta or dr dt d theta? All right, let me start from the beginning. So y equals, so is it this question? So it's this question right here. I'm sorry, I missed that. I was writing it down. All right. Well, this question, you can actually distribute that into there, but it makes it a lot harder. So what you got to use is product rule and chain rule together. So you get, let's take the derivative of this one. So it's 4 times 5t plus 4 to the fourth plus 4t times the derivative of the right side, the right function, which is 4 times 5t plus 4 cubed times 5. And simplifying that down equals 4 times 5t plus 4 to the fourth plus 4 times 4 times 5 is 80. So 80t times 5t plus 4 cubed. Is that what he had on there, or did he simplify it even more? Oh, what the crap? Hmm. I see why you're confused. Okay. Well, what's cool about this one, let's pull out a 4, 5t. So imagine this is one giant bracket. So you can pull out a 4 and a 5t plus 4 cubed. And this right here is where I usually write my t's like that. So I can tell. So that's 5t plus 4 plus 20t. All right. So you can add the 5t and the 22 together, so you end up with 4. He threw this one at y'all for no reason. You don't need the brackets. Those just help to visualize it. And that's one of the answers on there. So you see what I did here? So this is one of the answers. He just simplified what he really didn't have to. So you got any more questions that I could try to find? He had a lot of questions in this thing. That practice exam took me 2 hours, so there ain't no telling how long this thing took y'all. Number 6. Okay, let me see if number 6 is the same thing for you as it is for me. All right, my number 6 is that your number 6? Okay. Any more hints? Mm. So you only wrote down the number, you didn't write down the work for it? I have an idea. I feel you. I got an idea. All right, we're going to start from the top. This is number 1. I'm going to scroll through them real quick, and if you see it, let me know. Like, just send a message saying that number. So this is number 2, 3. I'm just not going to say it anymore. Oh, it's number 1? Oh, that makes my life easier. Okay, you want to find the derivative of that? All right. So it wants dr d theta, so r prime equals -2 times secant theta plus tangent theta, so -3 times the derivative of this. Derivative of secant theta is secant tangent. Let me rewrite that. Plus the derivative of tangent theta is secant squared theta. All right. So I'm looking at his answers now. I see why you're confused. Yeah. Yeah. Okay, so we're going to write this like this: -2 times, you can pull out a secant from here, secant theta times tangent theta. All over, since this is negative, you can put it on the bottom. All right. And you see how this is to the first power up here? And these are the same thing. So this one drops out and this turns into a 2. And then you end up with negative 2 secant theta over secant theta plus tangent theta squared. And that is an answer on there. You got any questions on how I did this one and how I combined it? There's a common factor. I pulled it out, and then for the negative exponent, I took that to the bottom so I could easily cancel things out if they were the same. He's not even really testing y'all on y'all's calculus skills. He's mainly testing y'all on y'all's algebra skills. Different kind of calculus professor than I've ever had. You got any more questions or any problems that you remember being particularly hard? Well, only really in the beginning of the test, so. Do you want me to scroll through it again and let you see? Okay. I'll scroll through it again and you just let me know the number. All right. All right. Had it come up? Yeah, okay. I'm guessing it hadn't came up yet. Okay. Oh, logarithmic differentiation. We're getting to that. It's not in here? No, wait a minute. This one? Okay, also 29. What about this one that I got up right now? Because there's 2 logarithm differentiations. Okay, you don't see that screen. It's popping up as a different screen. Great. All right, so that's number 9. Let me preview this again. This one? Okay. And then we'll go to 29 after that. So number 9. It was your number 9. Wow. What a stroke of luck. Using logarithmic differentiation to find the derivative of y. So y equals sine x square root of 5x plus 2. I would just use product rule, unless he's checking your work. I mean, you're going to have to use product rule either way. This is so dumb. You'd have to use product rule either way. All right, let's do logarithmic differentiation. Now, when you take the derivative of both sides, you get y prime over y equals 1 over all right, times the derivative there, which is product rule. So we're going to do sine x times 1/2. All right, you're not going to like this. I'm going to do 5/2 so I can save space. 5/2 because the derivative of the inside of the square root is 5. 5/2 times 5x plus 2 to the negative 1/2 plus cosine x square root of 5x plus 2. All right. You're not looking at my screen. Great. All right. I keep forgetting to switch back and forth. You know what? I'll know what I'm going to do. There we go. Here we go. All right. So you raise both sides to natural log. You take the natural log of both sides, and you take the derivative, and derivative of y, since it's implicit, it's y prime over y, plus the derivative of natural log is 1 over the function times the derivative of the function. And right here, the derivative of the inside was 5. So instead of writing that out to the right like I normally do, I was trying to save space. I just went ahead and said 5/2. All right. So I'm assuming the problem is with simplifying. So now we got to multiply by y, so y prime equals y over sine x square root of 5x plus 2. You're going to see why logarithmic was pointless for this problem. Times all this. Oh, what did you do that for? I just didn't want to write it. OneNote, come on, please. Nope, I guess it's not going to work. Okay. All right. So we have that. We know what y equals. Y equals sine of x over square root of 5x plus 2. So those drop out completely. And you're just left with, oh, my mouse is finally dying after like a year. Oh, we'll simplify this to make it look prettier. So this right here is your final answer. Whoa, why is that not an answer? What the sh... I'm guessing you're having the same issue as me in this problem. Well, I just typed it into a calculator and it said my answer is correct. The only thing you do is multiply through by this and you can get... Because when you multiply the side by square root of 5x over 2 over square root of 5x over 2, it turns this into a whole. So this is really all you can do. And actually, no, you can't do this right here. You can only put that right here. Even the internet agrees with me. Let me go back to his quiz. So you can't pull out a sine x. See, look, I did this over here. And it said use the product rule. And it gave me my answer. We can go see what the right answer was. I'll go see what the right answer was real quick. That kind of pisses me off. Okay. So C was the right answer, apparently. Cotangent is cosine over sine. Oh my Christ, he is such a freaking stickler. Okay. All right. Wow. All right. So what he did, he pulled out a sine x, and he pulled out a sine x, and he pulled out a square root of 5x plus 2. Let me see what the answer was again. Preview. No, I'm going to go over here, actually. Yeah. So he pulled out... And then so when you pull out the sine x from the first term and the square root of 5x over 2, and that gave you a 5 over 2. And when you pull out, this is a 5x plus 2 to the negative 1 over here, or negative 1/2. When you pull out another one, it gives you 5x plus 2. That's probably confusing you. Okay. I'm going to rewrite this up here. Equals All right. So these two are in the same form. All these are in the same form. What he did is he pulled out a sin x, so sin x and a square root of 5x plus 2. And you pull out a sin x that equals 1. You pull out a 5x plus 2. You're subtracting 1/2 from this. So you get a 5 over 2 times 5x plus 2 to the negative 1 plus, and you pull out a sin x from here, you get cosine x over sine x. And you pull out a square root of 5x over 2, you get nothing. This right here equals cotangent of x. And then therefore, he didn't make this any simpler by simplifying. He just made it more complicated for you guys for no reason. And this is what the answer looks like. Cotangent of x, we move that over here, plus 5 over 2 times 5x plus 2. And that was the actual final answer. How annoying is that? Did you see what I did there, or does it make everything worse? Yeah. I would have never thought of that either. Obviously, that's the right answer. This works. This works. It's all the same thing. He just wanted, I don't know. I don't know. All right, you said number 29 as well, right? All right. My number 29. So this is the problem, right? It's an initial value problem. All right. So you remember, we're going to rewrite this as dy equals 1/2 x to the negative 1/2 plus 7. And now we can, well, so now we can do integral of dy equals no, I'm just gonna leave it. All right. So now when we take the integral of dy is just simply y equals, and now you get 1/2 times 1 over negative 1/2 plus 1 times x to the negative 1/2 plus 1, because it's the opposite of derivative we're doing, because you want to know what y is, so we're doing the opposite of derivative, plus 1 over 0 plus 1 times 7 to 0 plus 1 plus c. All right. So y then equals, so 1/2 times 1 over 1/2 times x to the 1/2 plus 7 plus c. And these two down here cancel. So y equals x to the 1/2 plus 7x plus c. You understand how I took the derivative or the integral right there? I'll try doing a step-by-step to help you out. That sucks, dude. That happens a lot. And now we know that y of 4, let me get rid of these things. equals what? -5 equals -5. So -5 equals 4 to the 1/2 plus 7 to 4 plus c. Now we only have one unknown, so we can solve for c. So -5 equals 2 plus 28 plus c. So -5 minus 30 equals c. c equals -35. So y equals square root of x plus 7x minus 35. And that's your final answer. Because we had the antiderivative up here, we just plugged in what we got for c into that. Any more general questions, or you want me to do what I had planned? I had some L'Hopital rule problems planned. That was about it. I didn't know how many questions y'all would have. Would you like me to scroll through them again? See if you have any more questions on any of them, or? Okay, one of the word problems. Let's see which one you'd rather do. Okay, we're going to go to 35 and work our way backwards. This isn't one of the word problems, I don't think. Well, just message when you want me to stop. Oh, here we go. This one. No, this one. All right. 33. All right. All right. Number 33. Rectangular sheet. I'm just gonna write this out. No, I'm not gonna write it out. Can't really take pictures of OneNote on my computer and put it in there. I guess I can screenshot it. Yeah. All right. Give me a second. It won't let me screenshot right now because I'm recording. Un momento. All right, now I'll go to OneNote. All right. Booyah. All right, you're not even seeing this. Sorry. Okay. I really did not want to write all that out. So we have a rectangular sheet of perimeter. So P equals 2x plus 2y equals 27 centimeters. And it's rolled around a cylinder shown in part A. And y is your height of the cylinder. So in volume of a cylinder equals 2 pi r squared times h. Okay. So circumference equals x. It tells us right here that circumference equals x. So circumference equals x. And r equals x over 2. So we have the radius right there, r equals x over 2. And so and h equals y. So what we have to do is get this volume into terms of only one variable. To do that, we need to solve. So we have this equation right here. So I think I'm going to solve for h. Yeah, or for y. So y equals 27 over 2 minus x. So if you divide by 2 and then subtract x, this is what you get. This is your first equation. So you can plug in, and that also equals h. So you can come down here to your volume equation. Equals 2 pi. Remember that r equals x over 2 squared times 27 over 2 minus x. Following along this far? Any questions? All right. So now we're going to simplify this through and all that. So it's 2 pi times x squared over 4 times 27 over 2 minus x. And now if we that's ugly. If we multiply this through right here, you get, this is a 2, so it'll be 27 over 4 x squared minus x cubed over 2. We still good? All right. So now when we take the derivative and we do this, we get 27 over 2x minus 3 over 2x squared. And right now we're trying to find the largest volume, so we want a max. So to find the minutes and maxes, we need critical points. So when you got this derivative, you got to set it equal to 0. So now you have 1/2 x. Actually, now you can pull out 3 halves times 9 minus x equals 0. So CP's are x equals 0 and 9. All right. So you come down here to your number line. 0, 9. If you plug this into the derivative, if you plug in, let's say 5 to the derivative, you get positive, you get positive. You plug in a number greater than 9, you get negative. You plug in a number less than 1, you get negative as well. So this is a min, and this is a max right here. So what we're worried about now is x equals 9 because that's the maximum. So I'm going to come up here, and it wants to know the dimensions. And we know that x equals 9, right? We have that so far. So we know that x equals 9. And we have this equation. So 2 times 9 plus 2 times y, 27. 2y equals 27 minus 18. 2y equals 9. Y equals 9 over 2. Everything good so far? And that was the end of the problem because the answer is okay. It's just knowing your equation. What's hard about these is remembering all the geometry equations and then setting them up, figuring out how you have to do that. And it's obviously a long process. You want me to start scrolling again? Oh, he didn't provide the inverse derivatives either, did he? Yep. So those suck when they don't provide those because those sneak up on you. You're not going to remember those because who in their right mind that doesn't use them every day remembers them? Do you want me to scroll through the problems again and see if we can find another one? I don't blame you. If you want to head out, I don't blame you. I'm here till 2:25 though. Y'all need a break before y'all go on Wednesday. The rest of the course is actually easy, believe me. Just gotta trust me on that one. If you want to go ahead and head out, I don't mind. I'll catch you Wednesday. Okay, for the people watching this video on demand, I'm going to go through some L'Hopital rule problems real quick. Well, we got time, so that way y'all will just sit here in pure awkwardness. So we're going to start out with limit x approaches pi of sine of 3x over 2x minus 2 pi. Yeah, that equals 0 over 0. So now L'Hopital, so L comma H. That's how I let people know. And equals 3 cosine 3x over 2. All right. And if you plug that in, it equals 3 cosine of 3 pi over 2. That equals 3 times negative 1 over 2 equals negative 3 over 2. Nice and easy. All right. Sorry, I was just testing something out for my own curiosity. Limit as x approaches negative pi over 2 of cosine of 5x over sine 4x. And that equals 0 over 0. Because that'll be 2 pi, negative 2 pi, which is still 0. So now limit as x approaches negative pi over 2 of negative 5 sine 5x over 4 cosine 4x. And that equals negative 5 sine of negative 5 pi over 2, which is, or over 4 times cosine of negative 2 pi, which equals negative 5. Sine of negative 5 pi over 2 is sine is negative 1 over 4 times 1, which equals 5 over 4. Number 12, limit as x approaches 0, sine x, say number 12, sine x over x equals identity equals 1. Throwing that in there. This is number 12. Of 5x squared minus sine squared 2x over 3x squared equals 0 over 0. LH, or L'Hopital, you get 10x minus 2 sine of 2x times 2 over 6x. Funny enough, this still equals 0 over 0. So now we're going to keep the same thing, limit x approaches 0 of 10x minus 4 sine 2x over 6x. L'Hopital. Minus 8 cosine 2x over 6. And that equals 10 minus 8 over 6, which equals 2 over 6, which equals 1/3. So I'm going to do one more, and I think that's enough for you guys. I don't think y'all want to do any more. I think y'all probably mathed out, and I don't blame you. Sine of, I may do one more after this. Okay, so as you approach infinity, sine of 3x is between negative 1 and 1. So the range is always between there. This is approaching infinity. So the limit of this is equal to 0 because the bottom is getting bigger, but the top is staying in the same range. So it's going to just be pretty much 0 at that point. So the limit x approaches infinity of 3x times sine of 2 over x equals infinity times sine of 0 is 0. And determine it. Okay. So now, how do we do this? Well, what we can usually do is limit as x approaches infinity of sine 2 over x over 1 over 3x. And now we can do L'Hopital. So we get cosine of 2x negative 1 times negative 2 over x squared over negative 1 over 3x squared. Voila! X squared, negative, negative. And don't forget your limit. Infinity. So that equals cosine of 2 over x limit times 2 times 3, which then equals 6 times cosine of 0, which equals 6 times 1, which equals 6. Voila, everything works out nice and pretty. I think that's going to be it for today. I think everyone's pretty mathed out. So I hope y'all had or did okay on the test. I hope y'all appreciated my practice exam. I know it wasn't perfect. I got upset with myself too. I wish I could make it better. And I kind of hurried through the first part because I had to film it. But anyways, I will talk to y'all Wednesday or later. Please keep working hard. Y'all got a final coming up, and once y'all are done with it, as long as y'all pass the class, y'all are done. So I'll catch y'all later.